Math 2415, Calculus 3, Section 13.6, Parametric Surfaces and their Areas, Video 3. Planes as parametric surfaces. Let's reverse engineer a problem where we have a shape and we try to come up with the parametric equations that define the parametric surface. We're going to do this with a plane that contains a point P naught and two vectors in space, vector A and vector B. Specifically, the plane containing the point P naught whose coordinates are x naught, y naught, z naught, so we can describe it with the position vector r naught, just to show you where that is in here. P naught's the green point in the plane, r naught is the origin vector, the vector originating at the origin, terminating at P naught. But we want the plane to contain not only that point, but the two blue vectors A and B, which will be denoted component-wise as A1, A2, A3, and B1, B2, and B3. Written in blue here. In order to do this, we must, first off, I don't have this part drawn correctly. We must ask ourselves, what must be true about every point P in the plane? So I'll pick some random point P over here in the plane. Let me connect those real quick and make that vector again. And we'll call the position vector associated with point P vector R. Now, how can we describe point P relative to the given point P naught and the two vectors A and B? And the answer is pretty simple. Using A and B, we should be able to get from P naught to P by taking the correct scalar multiples. For example, we could go backwards some in the A direction and then over some in the B direction. So we would take some scalar multiple of U, of A, so we'll say U times A, and some scalar multiple of B, we'll call it V times B, and that should get us from R naught to R. So in other words, we're saying to get to R, we start at R naught, the point in the plane, we add some multiple of A, so U times A, plus some multiple of B. Actually, we have the vector equation right here. We could say that R of U comma V is equal to R naught plus U times A plus V times B. But if we wanted to take it down to the component level, we could. By saying that R naught is the vector, position vector x naught, y naught, z naught. Remember, that's just the position vector whose initial point is at the origin and whose terminal point is at x, y, z, x naught, y naught, z naught, plus u times vector A, which is A1, A2, A3, plus v times vector B, which is B1, B2, B3. So we can combine all these vectors and equate components. That means that our x component for R of uv, actually we can write this here, and we'll write it here. Our x function would be x naught plus u times A1 plus v times B2. Our second component would be y naught plus u times A2 plus v times B2. And our z component, our third component, would be z naught plus u times A3 plus v times B3. So we could say that this is our function, our x function in terms of u and v. This is our y function in terms of u and v. And this is our z function in terms of u and v. Of course, we could do it for a specific point and two specific vectors, but why do it specifically when we can do it generically once, and then you just use this result to come up with the parametric equations to define any plane as a parametric surface. You know what? That video was short, and I think a good example is in order. For example, let's say the plane contains the point 3, 1, 7. Vector A is the vector -1, 2, 0, and vector B is the vector 4, 7, 11. And we wanted to know the parametric equations that describe this plane as a parametric surface. Our x equation in terms of u and v would be the x coordinate, 3, of the point 3, plus the first component of A times U, so minus U, plus the first component of B times V, so 3 minus U plus 4V. Our Y component function would be the Y coordinate of the point, which is 1, plus U times this Y component of A, so plus 2U, plus V times the Y component of B, so plus 7V, a lot of letters here. And our Z component function, these don't have vectors, they're scalar functions. Shame on me. The Z scalar function, Z of U comma V, is the Z coordinate of the point, which is 7, plus the Z component of A times U, so 0 times U, I know that's 0, plus the Z component of B times V, 11V. Point, vector A, vector B. This reeks of how to write the equation of a line in parametric form when you have one point and a parallel vector. This is kind of the same thing. We just have two parallel vectors and therefore two parameters.